Hi everyone, this is Nitesh Soni. I'm a director for advanced analytics and AI for technology at Scotiabank. Just a quick intro, Scotiabank is headquartered in Canada and has global footprints. It has around 100,000 employees and is the leading bank in Americas. Bank has a core strategy around three pillars. First one is keeping customer first in everything we do. Be a winning team to deliver and drive the growth of the bank, and continue to be a leader in Americas in the high priority business area by outperforming others. And in order to support the overall bank strategy, advanced analytics and AI plays a critical role. And if you look at overall analytics within the bank, they are typically divided into three main buckets. One is customer centric. This is where leveraging big data and AI, we can improve the customer experience. Second is protecting the bank. This is where we call it as risk analytics, doing risk analytics, and also safeguarding our customer data. And the third one is around improving operational efficiency by modernizing the business core function areas. And what I mean here is, in order to run a business or a bank, we have various business units such as finance, technology, audit, legal, and so on. How we can embed advanced analytics and AI in these function areas to make them more effective, increase their operational efficiencies, and by doing so, actually, how we can stay competitive in the market space. So this is the area where I'm going to focus more in today's talk. And as I said, I lead a technology function area. So most of the use cases you'll see in this talk are coming from there. In addition to that, I would like to mention one more point here, that the the Scotiabank AI strategy, I think is there and it's pretty strong. But in addition to delivering the use case, we also are building a very strong data-driven culture by building a strong talent pool of data scientists and data engineers. And those basically have been fully integrated with business analytics professionals. Uh, to just in order to make sure that whatever the use cases have been built, they are delivered for the high business value or high impact business use cases. Okay, so this is just an example. As you know, that AI is not like plug and play technology. It is required to have a strong AI strategical framework. The first step in that is really to build holistic engagements, and it has various components you can think about. The first one really starts from a buy-in from the top leadership. Once we have that, then there should be a strong alignment among business lines, data analytics, and technology team. And also at the same time, it's very important to have a strong coordination with privacy, compliance, and legal teams. And in terms of starting the analytics, I think it's more important to understand doing this in more like an evolutionary approach, starting small, uh, small as you can think of converting raw data into some simple insights, and then start building other advanced analytics on top of that. More like you can think of crawl, run, walk, and fly analogies here. And while building this solution, also, it's important to keep in mind to build more sustainable solutions in the modern environment, and also making sure those solutions are reusable. And what I mean reusable here is the solution is not only meant to solve one problem, but with the minimum customization, it can be used to solve multiple problems. And reusability not necessarily is like a whole solution, but reusability should come from reusable the reusing the let's say analytical code, or reusing the data, or using the solution as whole. So it could be come from any part. And other component is the scalability, building solutions for solving one problem and then scale it to different problems, so to solve different problems, and or scaling the same solutions to different geographies with minimum customizations. And during the execution phase, I think it's important to put multiple skills that together to work in collaboration, such as the core AI team, should be working very closely with other cross-functional team who has business acumen and who can provide more like SME support. And then doing execution, agile execution work in a perfect way. I would say not say 100% perfect, but most of the cases it's perfect. Uh, and then project cycle, it has to be short. You cannot run any project which go beyond, let's say, 3 to 4 months, because I think idea here is to focus on the low hanging fruit, which can be built quickly and which can put into a market quickly to realize the benefits. If any use case required like a longer time duration, important to break into MPPs. MPP1 maximum 12 to 14 weeks, and then just put into markets, realize the benefit, and start building MPP2 and so on. I'll show you a few examples for this. And the last one is the test and learn mentality. It goes with the saying that uh, fail fast, learn fast kind of approach. This way we can move faster, we can build more sustainable and robust solutions. Okay, this is another example, how AI teams basically work with their business partner within the organization. There's engagement framework, there's a delivery framework, and engagement framework is really like, how do we make sure that the AI teams or analytics teams, they're working on the right problems. And this is where I think the first step is really to start discussing, initiate any of these ideas or use case, brainstorming all these ideas with the business, and asking our business partners what are their main pain points and how analytics can help them to solve. And then also talking about the requirements. Do we have the right data to solve this problem? Do we have right technology to solve this problem? Do we have resources to solve this problem? And how much is the budget? And at the same time, while we are discussing this, I think it's important to understand the financial best estimates, or any non-financial estimates of any use case. Any use case where we have low business value can be deprioritized. Any use case where we have high business value and high readiness can be, can be considered like the top prioritized use case. Okay, and then in execution phase, as I mentioned, I'm following more like agile approach, breaking everything into sprints, stand-ups, and so on, and keeping process life cycle typically 10 to 14 weeks, depending on the complexity of projects. One point I want to mention here, the discussion around the deployment solution, they should also start happening at the beginning of the projects in the engagement framework. And once it is implemented, I think the remaining thing is basically monitoring it, and also making sure if we want to convert everything into more like AI, then creating a feedback loop in a more automated way, so that the solution become more like robust and sustainable for futures. Okay. Next step is okay. So here I am going to give you a few examples of use cases, primarily coming from technology function area. So as you know, during COVID time, I think there were several challenges for all the organization, or small, big organization, and one of them was providing the resilient and stable technology. And what I mean, it could be like providing stable VPN network or email exchange and so on. Failure of any of these can impact business operations, and it can also cost bank a lot of money, as well as it can also contribute to losing the productivity of the business. I'm giving you one example here of network analytics of how to predict the network failures. So here idea is, before predicting, I think the MVP one here is to first understand, what are the root cause of network failure. And this is where what we can do, we can gather information from various monitoring tools, which can provide information around the devices, around the data jittering, data loss, or maybe connection failure, circuit failure. All that information we can gather and can start building the pattern analytics. Once we understand, then we go to the next stage, where this is where we can look into the correlation analytics and see how the correlation among different variables, different parameters looks like before any failure happen. So for example, here red dotted line is an example when there is some high level activity before any failure happen. Blue is a line when there is no activity before any failure happens. So we can identify certain characteristics, and using that information, then slowly we can start building the predictive analytics. And also, predicting network failure depending what exactly you want to see there, whether the failure happening in 30 seconds, 1 minute, 2 minutes, 10 minutes, what exactly you want to see. I think those sort of characteristics we can embed here. And based on that predictions, we can build some sort of actionable uh, activity. For example, if the prediction is saying that whenever the traffic on certain device is high, it should automatically divert that traffic to another device where the traffic is low, so that it can avoid any network failure. So this is one example, and the benefit of this sort of analysis is huge. As I said, losing a connection or network for critical application, even for 5 minutes, can cost a bank around half a million, 2 million, or maybe more than that. Another example here is around the vulnerability. As you know, vulnerability is defined as flaw in a system related to software, application, or server, or even the weakness in the computer itself. So, which are exposed to a threat, right? And these are happening all the time. And during COVID time, as you know, most of our customers went digital, and now I think more digital means we have more responsibility to protect their data, and at the same time, protecting banking assets from the attacks as well. So vulnerability management cycle is typically has 5 layers. One is to identify these vulnerabilities. This is where organization use a lot of scanning tools in automated way to identify them, and then to classify high, medium, low. High means really critical, and they should be prioritized for remediation quickly. Low means maybe less critical, and probably the organization can live with that for up to a certain period of time. uh, and then remediation activity based on prioritization. So if you look at the whole cycle, you can embed analytics at every stage. Basically, I'm giving you one example here. For example, here we built MVP1 is really like a self-serving analytics tool to classify vulnerability and asset detections. Here the challenge was like, we had like this separate data coming from multiple sources, identify those data elements, putting them together, and then creating more like a cohesive view. I think that is important. And it can also act more like a continuous monitoring tool. MBP2, basically combining this information with asset misconfiguration information to different kind of data set, and can be built more like a prioritization models to optimize the remediation efforts and maximize the risk reduction. I think that is the second kind of analytics. And the third stage, I think this is where you can use machine learning and neural network to predict vulnerability by combining internal data with the external data. So there's a huge variety of analytics which we can do here. Next example is from cybersecurity, which is important for all the organizations. And here I'm just, slating one example, which is around data loss preventions. And as you know, the data loss can happen in multiple ways. Even if you lose organization laptop, that is one kind of data loss. Or connecting to external network and if some malicious activity happen, that is another kind of a data loss. Or as via emails also, knowingly or unknowingly, some malicious activities can happen from the inside actor or from the outside actors, right? I'm just throwing one example here for data loss because of emails and how we can embed analytics here. So generally what happens whenever any email exchange within a bank or outside bank happen, it has to pass through a framework known as data loss prevention policy framework, which is designed based on certain rules. If any email does not pass that window, it creates a flag and then it goes to cyber team that review that flag. But just imagine this organization is quite big. It has 100,000 employees, and every employee starts sending emails, like on an average 10 to 15 emails per day. The volume of email would be huge, and the number of alerts generated by this email exchange would be huge. So it almost becomes impossible to review all those email alerts by the cyber team. Some of the alerts could be like, let's say false positive. They might not be legitimate. I can give you a few examples there. But anyway, so how machine learning can help there? I think idea is can be analyze those email logs in a real time, run some machine learning models and see and create some sort of a score. Any email where the score is high can be sent to the cyber security team for the immediate review. Any email which has low score, there can be reviewed later on. So that is one way. But on the other side, we can also use analytics to optimize the data loss prevention policy framework rules. So which are based on some what if policy rules. So can we build some certain models where instead of what if, we build more like a scoring based models so that any email come here and get automated scores, and if that score is below certain level, then it should not generate alerts, but if it's above certain level, then it should definitely generate alerts, and that will help to reduce the lots of false positive alerts. And the third example, which is very interesting, I would like to mention here is around text mining using NLP. For example, if you want to scan the contents or attachment types of attachments going through these emails, you can also apply NLP techniques to figure out whether the people are not sending any confidential or sensitive information within or outside the organization. So this is another example. So in the interest of time, I just want to say quickly on this slide, if we look at other function areas, so I gave you a few examples from technology function area. If you look at finance, audit, complaint analytics, or consent monitoring, both, for example, these are from operation side. You see, we can use variety of analytics here. For example, in finance, uh, in order to reduce the variance in finance forecast between the forecasted value and actual value, we can embed predictive analytics, and it can be very powerful, or it can be a more very powerful and strategic tool for the finance department. Same for audit function area. Moving away from a sample auditing to full auditing require again embed again advanced analytics and machine learning to be embedded in their area, so that they can prioritize the right branches or right sample to be audited. From the operation side, we can do a lot of NLP stuff, like complaint analytics. We can detect certain kind of complaint using topic modeling. We can also predict the complaint gravity based on customer profile and its behavior. Similarly, for consent monitoring, we can use speech to text analytics, analyze those text analytics, whether the FAs in the branches have followed uh, all the regulation and compliant or the guidelines before starting the conversations. So there are the variety of example here. And okay, so I'll stop here with these couple of or few closing remarks. That AI is a part of bank's core strategy, and in addition to customer analytics and risk analytics, there is a strong focus to modernize the function area as well. And I showed you a few examples, and believe me, there are a blend of AI technologies. Those are being used in variety of use cases. These are really helping to reduce operational costs, gain on operational efficiencies, and mitigation and operational risk. But certainly there are certain challenges to enable, execute, and adopt AI in this function area. What the progress is on the way. So thank you for listening. And if you have any question, please feel free to send me via chat or via LinkedIn messages. Thank you. Bye-bye.